Let's get started on your review over operations with polynomials. We're going to be adding, subtracting, multiplying, and dividing polynomials. First, how do we add polynomials? We just combine like terms. So it's really simple, and we're going to write our answer in standard form. So I'm going to start with the highest exponent, the term with the highest exponent, which is 5x squared. And I'm not going to combine it with anything, so I'm just going to write 5x squared. And then I'm going to move on to our linear terms. We have 7x and negative 3x. And notice in this case, I am actually underlining with 2 lines the terms that are alike, right? So I can only combine terms that are alike. So 7x minus 3x is positive 4x. So that becomes plus 4x. And now we're going to combine our constants, which is 4 and negative 6. And those combine to make negative 2, and that is our answer. That's our sum, 5x squared plus 4x minus 2. When we're subtracting polynomials, we're going to do the same thing, but what you want to make sure you do is distribute this negative into every term on the inside of the parentheses in the second polynomial, right? So that second set of parentheses. So this actually becomes, instead of, and what I do is I just write it like this underneath. That becomes positive 3x squared. This will become positive 2x, and this becomes minus 6. So where do students typically make mistakes is they only distribute that negative into the first term, but you want to make sure you distribute it into every term on the inside of the parentheses. And now we're back where we were when we were at the problem before. So we're just going to combine like terms. You can put a 1 right here if you want to put a 1 in front of the variable that doesn't have a coefficient, right? You can just put a 1 there. So 1x squared and 3x squared combine to make 4x squared. I'm starting with that highest exponent. Let's move on to our linear terms. 7x and 2x combine to make positive 9x. Moving on, our constants, positive 9 and negative 6 combine to make positive 3. And that's our answer, 4x squared plus 9x plus 3. Let's move on to multiplying polynomials. So here I have an example where we are multiplying binomials and an example where I have a binomial times a trinomial. So I'm going to show you the 2 different methods that I use to teach multiplying polynomials, and hopefully you find you have one method that you like, and that's the method I say to use every time. So in this first one, 3x plus 2 times 2x minus 5, I use FOIL. And it helps us to remember to multiply every term in this binomial times every term in this binomial. First terms, outside terms, inside terms, last terms. So I'm going to do it like this. 3x, we're going to multiply by 2x, and I get 6x squared. Then I'm going to multiply 3x by negative 5, and I get negative 15x. Inside terms, or really I'm just moving on to that next term, 2 times 2x. Now I'm going to multiply the second term in this first binomial times every term in this second binomial. 2 times 2x is positive 4x, and then 2 times negative 5 is negative 10. And now I'm just going to combine like terms. Negative 15x and positive 4x combine to negative 11x. So 6x squared minus 11x, and then minus 10. And there's my answer. So the other method that you can use if you don't really like, okay, I need to multiply x times every term in this trinomial and then negative 4 times every term in this trinomial. I find when you're multiplying a lot of terms together, some of my best students just make very small errors. They leave off, and I do too. I just will miss an exponent or something like that. It just happens. So you can always use the box method where I have a binomial times a trinomial. So what I'll do is I'll draw this box and I'll put x minus 4 over here, right? Each term gets its own row times a 3-term polynomial. So every term up here, 2x squared, negative 3x, and positive 1, it gets its own column. And so what we're going to do is multiply every term in the columns times every term in the rows, right? So they just meet. 2x squared times x becomes 2x cubed. Negative 3x times x is negative 3x squared. 1 times x is 1x, or just x. Moving on, 2x squared times negative 4 is negative 8x squared. Negative 3x times negative 4 is positive 12x. 1 times negative 4 is negative 4. And one of the reasons I like this method is you can see that when we combine like terms, everything that I wrote in yellow there, I'm going to combine. 2x cubed, I can't combine it with anything, and that's my highest exponent. But right here, my diagonals are the same. I can combine those. Negative 8x squared and negative 3x squared combine to make negative 11x squared. So a lot of my students that I've had that struggle with this is the point we multiplied before. This is the point where we add. When we add, the last name stays the same, right? The x squared stays the same. Moving on, 12x and x, that combines to 13x. Last name stays the same, right? That x's stays the same. The x stays there, okay? And then negative 4. Okay, moving on to, and you can decide which way do you like to multiply polynomials. If I'm going very quickly, this is typically my go-to method. This, I tend to see fewer mistakes from students who use this method. So moving on, we're going to talk about polynomial long division and synthetic division. First, long division, what we're going to do is we take this polynomial, our dividend, 6x cubed. What in the world did I just write there? I was looking at something else. 6x cubed minus 7x squared minus 29x minus 12. And I'm going to divide it by this binomial right here, which is 3x plus 4. So polynomial long division. 3x, what do I multiply 3x by to get 6x cubed? I multiply it by 2x squared. 2x squared times 3x is 6x cubed. 2x squared times 4 is positive 8x squared. When I'm using polynomial long division, I subtract. I like to put the parentheses there because we need to make sure, just like when we subtracted polynomials earlier, you distribute this negative into each term inside the parentheses. So this becomes negative 6x cubed and negative 8x squared, minus 8x squared. These cancel. Negative 7x squared minus 8x squared is negative 15x squared. And what's my next step? Bring the minus 29x down. And then we're moving on. What do I need to multiply 3x by to get negative 15x squared? Negative 5x. So I write negative 5x. Negative 5x times 3x is negative 15x. Did I say negative 3x? Negative 5x times 3x is negative 15x squared. Negative 5x times 4 is negative 20x. What do? Subtract. When I subtract, I distribute that negative, and I get that becomes a plus, that becomes a plus. And now, these cancel. Negative 29x plus 20x is negative 9x. Bring down the next term, minus 12. What do I multiply 3x by to get negative 9x? Negative 3. Negative 3 times 3x is negative 9x. Negative 3 times 4 is negative 12. And then I'm going to subtract. And when I do, both of those cancel. I have a 0 remainder. And my answer is 2x squared minus 5x minus 3. And how can you check your work? 2x squared minus 5x minus 3 times 3x plus 4 will give you this polynomial right here. Moving on to synthetic division. When we're working with synthetic division, you can only use it when your divisor is written like this, okay? X plus 3, x minus 4, x plus 2, meaning you don't have a leading coefficient other than 1, right? So you're not going to have this right here, 3x plus 4. We wouldn't even be able to use synthetic division on this long division problem right here, okay? So let's move on to synthetic division. How does synthetic division work? First, I'm going to put my dividend in here, right? this 6x to the 5th plus 18x to the 4th, but I'm only going to use the coefficients. Starting with 6, then I've got 18, but notice I don't have a term, an x cubed term, or an x squared term, but I do need a placeholder. So I've got 0 for my x cubed term and 0 for my x squared term. -1 is the coefficient for the x, and then -3 is the constant. X plus 3 is the divisor. So what I do is I set that equal to 0, x equals -3. That's what I put here. So little shorthand is just the opposite of 3, right? So I'm going to put a -3 out there. And then I'm going to draw my line right here, and we're going to work through this. I'm going to bring down the 6. I multiply 6 times -3, and I get -18. And I add. Long division we subtract. Synthetic division we add. I get 0. 0 times -3 is 0, and I add. I get 0. 0 times -3, 0, and I add. I get 0. 0 times -3, 0, and I add and get -1. -1 times -3 is +3, and I add to get 0 as my remainder. So what's my answer? Here's the term for the constant. Here's the x term, x squared term, x cubed term. Here's the coefficient for the x to the 4th term. So 6x to the 4th, I don't have any other x cubed, x squared, x minus 1. And there's my answer. How do you check your work? 6x to the 4th minus 1 times x plus 3, and you'll get this polynomial right here. And that concludes your review of your polynomial operations. I hope it was helpful.